Hello and welcome back again. Today we're going to learn about something called solubility and solubility curves. And I know you might be thinking, wait a second, I know about solubility already because we've talked about it. We've looked at solubility charts, we've identified something as being aqueous or not aqueous, so we know how to identify precipitates and non-precipitates. What we're going to talk about though is a little bit more detail about solubility. What does it actually mean? How much is dissolved in this case? How do you determine what can be dissolved? And that's where solubility curves are going to come into play. A solubility curve allows us to identify at a certain temperature how much of something can dissolve in the solvent that you're talking about. So we're getting a little bit more specific. Now before we get too crazy about talking about solubility, let's review real quick some terms. So a solution, you hopefully remember, is a homogeneous mixture, which essentially just is any kind of mixture where you cannot see the different parts. So everything is very kind of evenly distributed, it all looks uniform throughout, you can't pick out the different pieces, which would be like a heterogeneous mixture. In a solution, there are two main parts. You've got your solute and you've got your solvent. Now the solute, hopefully you remember, is the thing that gets dissolved. The solvent is what does the dissolving. So when we talk about like molarity, for example, the moles would be your solute, the moles of whatever substance you've dissolved. The solvent would be the total volume of everything. So when we talk about molarity and we talk about the volume, we're talking about the entire thing, including the solvent and the solute. So back to solubility. So solubility is the maximum amount of solute that you can dissolve in a certain amount of solvent. So now we're looking at the total max you can get. And this is going to depend upon the temperature, and it's going to depend on if you're talking about a solid or a gas because it changes slightly. Some solids are more soluble than others, and the same thing for gases. And it also changes depending on the temperature. And what you get is a solubility curve that forms. And looking at the solubility curve, you can identify based on temperature how much of something is going to dissolve. So it's a way of predicting it. So when we get into this whole solubility thing, eventually we're going to talk about something called saturation. And saturation is basically how much stuff you've dissolved. So we have these things called degrees of saturation. A saturated solution is one that is full with solute. Basically, that solvent is holding the maximum that it possibly can. Can't hold any more. If you were to pour any more into that solvent, the extra would just fall to the bottom. Think like if you're making Kool-Aid and you put your sugar into it. You stir so much sugar into it, but if you put too much, it all falls to the bottom, and then you got this kind of gooey, soupy mess at the bottom, which some people like, other people don't. I think it's kind of gross. So that's a saturated solution. An unsaturated solution is one where you still can dissolve more stuff. So you've added a little bit of sugar into it, you dissolve it all, you taste it, it's not quite so perfect yet. You can still add some more sugar to it and dissolve more into it. That's an unsaturated solution. So saturated holds as much of it as it can. Any more you add to it, it's just going to fall straight down to the bottom. Unsaturated, you still have room to dissolve more things. Now, the whole idea of saturated and unsaturated is going to change depending on the temperature, as I said before. There's one other type of degree of saturation we need to talk about, and that's supersaturated. So supersaturated is when you have a solution that's actually holding more solute dissolved in it than it normally should be able to. Now, that might seem kind of counterintuitive because you're like, wait a second, if it's already holding the max it can, and we just said you can't hold any more, how do you get any more to dissolve? Well, you have certain conditions you have to set it for. Typically what happens is we heat up the solution, dissolve more, and then you let the temperature cool back down. And as long as you don't disturb that solution too much, it should work pretty well. But most of these are very touchy, so as soon as you disturb it by tapping the size of the container or dropping in any extra, it all kind of settles out, and you get some rather dramatic looking things that occur from this. And what we're going to do is look at a quick little video. Now this video is going to show you a demonstration of a supersaturated solution of sodium acetate. I'm actually going to do this in class also, but just so you can kind of see a video of it, if you look very carefully, it's going to look like a totally clear liquid, and if you watch real close, you're going to notice that a little single drop of another little grain of sodium acetate will be dropped in. And you can see it kind of spider webs outwards. It instantly disturbs it, instantly causes all that extra stuff to pop out of the solution completely, because the solution was holding way more than it was supposed to be able to. Once you've got a supersaturated solution, if you alter the conditions at all the extra stuff that's dissolved falls out, and you end up with the saturated solution on top of all the dissolved stuff. And like I said, we'll see this in class a little bit more, and I'll show you just how much stuff we're actually dissolving in. It's actually quite intense. So as we talked before, solubility depends on a number of different factors, and one of the biggest ones is temperature. If you want to dissolve more of a solid, you typically just raise the temperature up of the liquid, and you'll get more stuff to dissolve. The solubility also, of course, depends on the amount of solvent. If I have 100 milliliters versus a whole liter of water, obviously I can dissolve more in that 1 liter than I can in that 100 milliliters. The type of solute is a difference too, so different solids will dissolve at different rates. So sodium chloride versus, say, potassium chloride. They're going to dissolve slightly differently based on the molecules that you're looking at. the surface area can affect the solute's dissolvability. So essentially, if you can grind it up into a fine powder, it's going to dissolve much better than if you just put like a big block in there. So think like a sugar cube versus like a packet of sugar. The packet of sugar would dissolve much better because the surface area is better. It's more spread out. In the case of a solution like this, the surface area increased within the solute just makes it come in contact better with the water, so the polarity of the water is able to get it to dissolve better. So when we look at graphs, meaning the solubility curve graphs, those graphs are for specific solutes with specific solvents, specific amounts of solvents, and at specific temperatures, lots of specifics. But if you change any one of those factors, the curve will change slightly, either going up or down. And we're going to look at a lot of these in class. So solubility curve is literally just a graph that shows the solubility of a solute at a specific temperature. For solids, as you increase the temperature, the solubility goes up. So if you look at the picture over here on what I think is your right, you'll see that it kind of curves upwards. That's a solubility curve, a generalized one for a solid, because as you increase the temperature, more and more dissolves. And if you look really closely, you can actually see that. If we look here at 160 grams of this solute will dissolve when you're way up here close to almost 90 to 95 degrees, versus if you're at only 40 degrees, you're only getting a little bit closer to like 95 grams dissolved. So as you increase that temperature, you drastically change the amount of solute that can dissolve. On the flip side to that, gases, they typically will decrease in solubility as the temperature goes up. So if you look over on the graph down here on the left, you can see that as this curve kind of angles downwards, what you end up with is less gas being dissolved as the temperature decreases. So an easy, quick example of this is think like a can of pop. If you have a cold can of pop and you shake it up, it's going to pop and fizz a little bit, right? But if you take one that's warm, one that's been sitting out for a long time and it's warmer, and you shake the heck out of that thing, that's going to spray all over the place. So gases are much less soluble as their temperature increases. So if you want to really dissolve a lot of gas, you want a low temperature. If you want to dissolve a lot of solid, you want to increase that temperature. All right, so hopefully at this point you have a really good idea of how solubility curves work and about the differences in degrees of saturation. We'll talk a lot more about this in class as we'll kind of look at how you identify if something is saturated or unsaturated just by using the curve. And I'll also demonstrate in class a couple of these things as well to show you how you can alter the solubility of stuff. Remember to write down any questions you have so you don't forget them. Bring them with you to class and we'll go over them. Thanks for paying attention. Talk to you later.